Binary search interface. This is an interface, not a concrete class. In this interface, let's just talk about its high-level abstractions of some of the features we see binary search tree concrete class. The interface, it's very simple. It has a couple of key points. One is it implements a collection interface that we have from the previous chapter. Now, this is collection interface, not in the Java native library. The other implementation is Java's library's iterable interface. Recall your Java library's iterable interface is an implementation of iterable that provides an iterator. So in other words, once you implement this iterable interface, your goal is to produce an iterator. Iterator is also another Java interface. You should be able to look it up, what this means. And we'll go through the specific examples in our binary search tree from implementation standpoint. Because this entire interface wraps around a group of elements. Depends on how concrete class uses it. It could use an array, linked list. So that's your underlying buffer, which produces the iterator. It has next, and remove features. That's number one. And the other one is the support for max and min operations. The binary search tree allows one to find the maximum element or the minimum element. So this could be an integer, it could be a string where you can do lexicographical comparisons and whatnot. So min and max operations is provided as an abstraction into the interface. And the other one is the support for pre-order, order, post-order traversal. So let me just explain what this means. Once you traverse through these elements inside a tree, you want to store the tree somewhere inside a linked list or some sort of data structure. Once the traversal is complete, the entire snapshot of your tree is captured inside that ADT. So in the beginning, this is what we may have. We have a tree. Once you do the traversal, it becomes an ADT. Let's just say the end result ADT is a queue. This allows you to pre-order, in-order, post-order, to kind of capture the entire tree, which is in memory, into this ADT, kind of like flatten the entire tree into this queue. This underlying ADT is your choice. As we do later on, binary search tree concrete class actually uses a queue. So this is a quick summary of the binary search tree interface. If you moved into the next step, you can see the actual code. It specifically lists out the minimum and the maximum access source method, as well as the enum. What is the enum? Enum is a special class in Java that represents a group of constants. We specify whether the traversal itself is going to be using either in order, pre-order, post-order. As soon as the traversal order type is discerned, we use that traversal order. Let's just say if this is using in order. And this is what we do, pumping into the get iterator. And the reason why we have get iterators is because of an iterable that we implement, which is this one. Allows us to create that snapshot or that flattening effect, flattening everything from the tree into this current ADT that we can use to find max and then use to find min. So this is a quick summary of what this interface is. And let's talk about iterator in the next slides.